you guys are seeing how many people are logged in right now?
Yes. Okay. Hello. I believe it is time to start. Hi, everyone. I'm Marcy Sutton. I'm here with a cast of my colleagues. We are here to talk about technical accessibility today. So we're kicking off the Evincible series of accessible deep tech talks, in which we'll dive deep into discussions around accessibility test automation. As a developer who's worked a lot on accessibility testing tools, JavaScript frameworks, websites, and web applications, this is a topic that's close to my heart. Evinced, the company, you're just becoming familiar with them. They asked me to help them launch an event series bringing technical accessibility expertise to the public to really get in the weeds, like I would if I was in a room with other developers and other colleagues. So I'm thrilled to introduce this first event to you, along with some expert colleagues of mine who you'll meet a little bit later, after a couple of lightning talks from Evinced. So since this is the first event in the series, to stay updated about future events, what's happening with Evinced, you can register on the evinced.com website, and recordings will also be made available here on YouTube. So to start things off, we're going to hear from Naveen Tadani. Oh, wait, actually, before we do that, we have a code of conduct that I need to cover. So we want to keep this event safe, friendly, approachable, professional. So we have a code of conduct, and this includes the chat. If you're talking about this event on Twitter, we'd love some cooperation there as well. So this event is really focusing on accessibility and how the internet should work for everyone. So yes, conduct yourselves appropriately. Okay, so our schedule for today, we're going to start with the lightning talks from Naveen and Gal from Evinced. Then we will go into a panel discussion on the state of accessibility automation, and we'll have some time for Q&A at the end. So if you want to provide questions in the chat, we will be going through those and coordinating them with our panel discussion. Okay, so to start things off, on our lightning talks, Naveen Tadani and Gal Moab from Evinced are going to show us a couple of lightning talks about what the company is working on. And then we'll use that information as a jumping off point for the panel discussion. And we really want to talk about innovating with accessibility automation in responsible, ethical, creative ways. How can we move this forward in the best ways possible? And let me be the first to say that accessibility can't be solved with automation or computers alone. There will always be human effort and manual testing required to create truly accessible user interfaces. But I also believe that we can use computers and algorithms to reliably identify more accessibility issues, and we can then apply human effort to things that require more nuance or detail. So without further ado, let's hear from Naveen and Gal from Evinced.
Thanks, Marcy, and hi, everybody. Thank you for joining. We're really excited to kick off this Deep Tech series, so I'm going to jump right in. And what we're going to talk about today is a little bit of an overview of events, so you have a bit of a context in terms of where we're coming from. I'll talk a little bit about our technology development areas and some of the areas that we're focused on in terms of algorithm development in order to advance the state of automated testing in the industry. And there are many different things that go into it, but today we'll deep dive a little bit into some of the detection algorithms that we're working on. How can we figure out more accessibility issues automatically, right? So that's a big focus of today's discussion. And in that, Ben, my colleague, will also demo this using computer vision and machine learning as some algorithms that will help us to identify elements, and we'll explain why that's really important in this whole thing. And then I'll hand it back to Marcy for the panel discussion. All right, so starting out with what is Evinced, and I think sometimes it's better to talk about what we're not. And straight right up front, I want to state that we are not an overlay company. We do not attempt to fix your code automatically, and that is absolutely not something that we do. And we're also not saying that our technology can detect all accessibility issues. We fully acknowledge that manual testing and audits are important, and they will always be important, no matter how advanced the state of automated testing is. And on top of that, user testing is also very important to get feedback around the UX and UI elements when it comes to accessibility from real users. So of course, those two things are critical. And then I also want to state that we don't really provide any of the manual testing or audit services. We partner with the industry and the ecosystem, independent consultants, systems integrators, and other specialist firms in order to deliver those services. So what exactly are we? Evinced is laser focused on technology development. We're a technology and product company, and we're focused on the next generation of automated testing for accessibility. And our products are centered around websites, web applications, and of course, even mobile applications. So that's what Evinced is all about. And our goal is to be able to help enterprises weave accessibility or integrate that into their development process, their software development process, as well as their operations processes. So we have products like browser extensions and automation SDKs, as well as instrumentation SDKs, and scanning systems that can help you. We'll dive into all of that later at some point in time. But our goal, again, is to help enterprises integrate accessibility into their software development and operations processes. On top of that, we're sort of backed by Microsoft Ventures and BGV and other leading Silicon Valley firms. So we've got enough resources right now to really kind of invest significantly in R&D and try to advance the state of automated testing. So the areas that we are really focused on from a research and development perspective are really three categories of things. The first one is to be able to automatically detect accessibility issues, right? So these are the detection algorithms. But it goes beyond just detecting these issues. It's also about pinpointing where they are, which in a lot of cases can be pretty challenging, and also suggesting fixes. Now, the more in context your fixes are, or suggestions for fixes are, the easier it is for developers to actually just implement them. That in and of itself can be pretty challenging. So there's a lot of research and development work in that first bucket. But then it's not only that. We think that in order for accessibility to be integrated properly into the development process, you also need to have a bunch of analysis algorithms that really help reduce the noise. When you do an accessibility analysis, let's say it's a scan across thousands of pages, and each page has hundreds of issues, it's very easy to end up flooding the development team and them not knowing what to do with it, right? Because there are tens of thousands, if not hundreds of thousands of issues sometimes. And that really is a problem. So we think that the right approach, while there might be hundreds of thousands of instances of problems, you can, with algorithms, reduce that to a much more solvable set, if you will. So if we can identify that all of these particular issues are arising from this repeating pattern of code or a component, that's a very meaningful thing, because it really kind of helps development teams digest this information, focus their remediation efforts in the right places. That's of course one thing. But you also want to be able to assign unique IDs to issues and things, so you can track them between different scans or different analyses. You know if there are regressions, you know if there are new issues or old issues, how long they've been open. All of these things need a very robust unique ID infrastructure. So there's a lot of that. That's the second bucket that I'd classify in terms of analysis algorithms. And then finally, the products as well. There's a lot of development work that needs to go into products to make them very easy for developers to use, very easy to integrate into the CI process or the automated testing process. You shouldn't have to call certain functions and hook them into different parts of code, decide how you want to do it. There should be, a very simple one line of code integration into whatever existing automated testing framework you got. And you just get the results, and they've nicely got the analysis with them and all. So there's a lot of product-oriented development and sort of research work as well that needs to be done. But before we dive into that, and before I turn it over to Ben for this section, we're going to focus on the detection algorithms. And the fundamental thesis that we have is that while static analysis or syntax analysis even has done a good job in getting us to where we are right now, and we can detect quite a few issues that way, with the web becoming more interactive, it becoming more based on JavaScript and more sort of interactable from that standpoint, you can very easily with syntax analysis miss some pretty critical issues when it comes to accessibility. So we think that the syntax analysis approach needs to be augmented with something else. Now let's consider this example. So if you have a piece of code where there's some code and then there's a div and then there's some more code after that, and you look at it with traditional syntax analysis tools, you will not find anything wrong with this. Why? Because a div is actually a perfectly legitimate HTML element. Divs, spans, images, all kinds of things, and they're powered by JavaScript functionality somewhere. It's impossible to detect that with syntax-only approaches. So we think something else is needed fundamentally on top of that in order to be able to detect the next series of validations or accessibility issues that we will be able to cover. So that's the fundamental sort of problem that we're trying to track with the technologies we're developing. Now, if you look at this problem in a different way and you turn around and say, well, okay, what if we could analyze the UI and the UX of the website or the web application, and we can know conclusively that a particular element is a button. And then when you look at the code underneath that, you can very easily tell whether there's an accessibility issue with this or not. So for example, if I know that this thing is a button and the code underneath represents just a div and it's got nothing else with it, then we know clearly that this is going to be a screen reader issue and a keyboard issue. So that's something that it's all predicated on knowing what these elements are. So a big part of the algorithms that we're developing are about trying to get different kinds of clues around figuring out and conclusively stating at the end of the day what that element is, and then looking at the code to try to figure out if it's implemented correctly or not. So in this particular case, of course, now that we know it's a button, we know that there's going to be a screen reader and a keyboard issue, and the way to solve that is to either implement it as a button, which has the semantic elements in it, or add a role to indicate to a screen reader or other assistive technology that this is interactable. So that's fundamentally the premise. We need to know what that element is, and then we can detect a lot more accessibility issues automatically. So I'm going to turn it over to Ben now, who's going to dive into more detail around how our system works and explain some of these different concepts, and then dive into the machine learning and AI experiments and research work that we've been doing. So over to you, Ben.
Thank you, Naveen, and hi, everyone. My name is Gal, and I'm the VP Product and co-founder of Evinced. Let me use this diagram to explain our approach. So, as Naveen mentioned before, we start at the UI UX level, at the user experience of the page. We use a range of algorithms. Some of them are rule-based, some of them are ML AI, machine learning, and artificial intelligence. Some are computer vision to compute a semantic model of the page. Semantic model basically means a list of components or elements on the page, a UI elements on the page, and a list of attributes of these elements that describe their behavior, their expected behavior. Once we have the semantic model, we can use the comparison engine to compare it to the syntax of the page, basically the DOM and the way the DOM would be interpreted by assistive technology. And once we can compare the two, the discrepancies are basically the accessibility errors. We extract these errors and we extract their location and other information to build a report basically that describes the issues on the page. So in this short talk, we only touch a little bit at the machine learning and artificial intelligence algorithms. Let me dive into it. So what are we trying to solve with MLAI? The main thing we're trying to solve is the component classification problem. So understanding what are the boundaries of the UI elements on the page, and then what are their attributes that describe their behavior, the same behavior that needs to be expressed also to assistive technology. We also use ML AI and computer vision to do to detect focus indication issues, which we'll talk about later, as well as color contrast. So we started our journey with collecting a set of components, a data set, basically images and code snippets of a lot of components from the web. We figure out a way to automatically tag hundreds of thousands of pages, scan them over the web, and extract hundreds of thousands samples of buttons, input boxes, drop downs, and so on. With this data, we build classifiers. Basically, we use supervised learning. We started very simple with simple classifiers with few layers, few layers network, and slowly we increase the complexity using algorithms like ResNet and alike. And as I mentioned before, the goal is to classify the different elements that we found into groups. So let's see a demo. So this is one of my favorite demo sites. It's a real site, a European train ticket booking site. And the reason I like it is that it's very clear to understand when you look at it as a sighted person, what is the intention of the site. There is a form, a very clear form here with 4 input fields, and all these input fields clearly looks like drop down. So if I'll click at them, they would open up something for me to choose input, and there is a search button. Let's run the algorithms and see what they found. So this is a little research extension that we've built that is designed to run the algorithms on the page. Okay, so we see that indeed the network had found that the 4 boxes here are drop-down input fields with high certainty, and this element is a button. And again, it is very clear for a sighted person. But let's see how the DOM really looks like for these elements. Let's inspect the first drop-down, and we can see that this is actually a div. And as you all know, div has no semantic. It's just a placeholder. So what would happen here is that the screen reader would read it as simple text. It would say select countries. We can obviously look at the accessibility tree and see a generic element and select country. So this is an example of this discrepancy. We as sighted people can see this to be a drop down. We know that we'll move our mouse here and click on the drop down, but the way it looks like from the DOM perspective, it's just like a div. This is the missing semantic information here. And the only way to understand the differences is by understanding the expected UX, the expected user experience. So let's see our extension in action. This is the Evinced Flow Analyzer. I'm going to fire it by clicking at the extension button, and I turn on the extension, and we already see 20 issues on the page. I can highlight them, and we can see that this is indeed an interactable role and keyboard accessible. We'll talk about the different validations soon. But interactable role basically means that the element is not interactable or would expose itself as not interactable to assistive technology. There is a discrepancy in the role of the element. The other thing is keyboard accessible, which basically means that a keyboard user won't even reach this element. We've seen that it's a div and it doesn't even have a tab index on top of it. And this is also the case for the other elements. Here the button just has a color contrast problem. The other nice thing about the Evinced extension is that it follows the DOM as I'm performing interactions. So when I'm clicking at the element here, you see that we have a complex widget that's being popped up. And there are all kind of other elements that also has issues. So for example, this clear on button itself won't be accessible for or interactable for a screen reader and won't be accessible for a keyboard user. We can look at this element, for example. It's a very complex element, and we can see that all the widgets on top of it are also not accessible. The buttons here wouldn't have accessible name, and so on. By the way, this is a good example for the fact that the, uh, the fact that the element looks like a drop down from a first sight doesn't mean that it is a drop down by the book. It might be a complex element, obviously, when I click on the drop down, and it's true for any type of element. So as I mentioned before, these machine learning and AI algorithms are not enough in order to tell the entire story. They provide us a lot of clues because they tell us what would a sighted person would expect, or some of the aspects that the sighted person would expect to find when interacting with the element, but not all of it. So that's it for our demo. Let's get back to the slides and talk a little bit about the validations that we find, the issues or the test that Evinced is running on the page. So we've seen before the interactable role, and as I mentioned before, it described the fact that an element on the page, a UI element on the page, doesn't convey its interactive role to assistive technology the way it should. The second is accessible name, which basically means that there is an interactable element on the page that doesn't have an accessible name. It's a little bit more complex or deep than missing a name for a button or missing an alt on a link, because the interactable elements here could be a bunch of divs or complex elements that are not not interactable elements by the definition. But they are interactable for the user and should be presented as such for assistive technology. The third one is the keyboard accessible, which basically means that keyboard interface won't reach the element. The fourth one is slightly different. This is a DOM order validation. It looks at the visual order of elements on the page and compares it to the order at which the elements would be presented to assistive technology. The fifth one is noise analysis, and it basically looks for elements that would appear on the DOM for a screen reader or a keyboard user, but won't be available on the visible page. So these are elements that would probably expected not to be reached and not to be interacted at the current state of the page, though they would still be available on the DOM. So these are the five first validation, and the next three are lab validations. So there are validations that are working in our lab, but not yet in production. The first one is relationship, that basically search for ARIA attributes that describe the right relationship between elements on the page. So if you, for example, interact with the drop-down button, you would expect that something on the DOM would pop up, and the elements need to be correctly associated using ARIA. And this is what this validation is checking for. The next one is focus indication, which is basically a computer vision based validation that looks at the focus ring of the element and computes how visible it is, or how prominent the addition of the focus ring is on the element. And the last one is text on image, which is basically color contrast validation that is designed to work on top of a background that is not necessarily constant. So it could be an image, it could be a background with gradient. It uses computer vision and some machine learning with it. That's it. That's it on my side. And to you, Marcy. Thank you.
All right. So that was Gal Moab from Evinced. He's the CTO, I believe. We were originally going to hear from Ben Bracha, who is another VP at Evinced, but we changed things up for you. So that was hearing from Naveen, CEO of Evinced, and Gal also from Evinced. So we've gotten a bit of a rundown of how Evinced Tech works, and we're going to use that as a jumping off point for our panel discussion, which comes up next. So to transform our event into the panel discussion, I'm going to introduce our three panelists. So this morning we're joined by three panelists, starting with Jesse Beach. Jesse Beach's technology career started formal linguistics, shifted to UX design, and then landed solidly in software development. At Facebook, she leads teams who build tools that support accessible interface development. She believes that all humans should have access to information and services, whatever their abilities or circumstance. So, hello, Jesse.
Hey, good morning, everyone. Thanks for having me, Marcy. I'm really excited for the conversation.
Same. Thank you for joining. We also have with us Cameron Cundiff. Cameron is a software development leader at Adobe, immersive tech pioneer, and accessibility specialist. Hey, Cameron.
Hey, Marcy. Thanks for having me this morning.
Awesome. And you can find Cameron on Twitter at CKUndo. Okay, and so thirdly, we have Jennison Ascension, who is the head of accessibility engineering evangelism at LinkedIn. He's a co-founder of Global Accessibility Awareness Day, which is coming up on May 20th. And every year we love Global Accessibility Awareness Day. And Jennison is also a highly influential digital accessibility mentor and connector. Hey, Jennison.
Hey, good morning, good morning, Marcy, and good morning, everyone. I can't believe we are hitting our 10th anniversary for Global Accessibility Awareness Day. So Joe Devin and I are really looking forward to everyone participating with us on May 20th.
Love it. 10 years. That's a big one. So we're, thinking about accessibility now and every day, but especially on May 20th. Okay, so we're ready to get started with our panel discussion. And I want to start by defining the word validation because we're trying to center our discussion. Accessibility and accessibility automation is so broad, and we have, just about half an hour. And so I want to start by defining validation to set up our first question. So validation meaning a procedure used for checking that a product, service, or system meets requirements and specifications. For accessibility, we have the Web Content Accessibility Guidelines, or WCAG, with its success criteria, some of which can be validated automatically and some which can't. And so examples could include color contrast ratios, which could be sampled and computed mathematically with a computer, or keyboard operability, which has had some limitations in the past, but as we saw from Gal's demo, we can start to use computer vision and artificial intelligence to identify issues on a page, try and float them up to developers. So things are evolving a bit. And so with that in mind, I would love to ask the panel, what does accessibility automation currently do well in terms of validations? And we could start with you, Jennison.
Sure. I was worried you were going to give away all my answers in your examples. But in the interest of time, I'll just say that three areas where I see validation working really well. As you said, color contrast is one. When it comes to the area of ARIA and making sure, although many of us in accessibility always say, first rule of ARIA is not to use ARIA. If you're going to use ARIA, many of the test automation suites out there will flag bad implementations of ARIA. And the other thing is the automation is good for checking, validating the presence or absence of things. So the presence of text for an image. Now, I'm not saying it's going to be checking that it's meaningful or that it's correct, but at least it's there. And same for names of things. So those are the three areas that I would point to.
Anything that you'd like to add, Jesse or Cameron?
Yeah,
No,
maybe a
that sounds great to
mental
me.
model.
Go ahead,
Go ahead,
Jesse, you're
Jesse,
on
you're on the
screen.
All right, I'm on screen. Great. Just really quickly, a mental framing for validation that I've been using lately is to talk about mechanical correctness versus semantic correctness. And validation and the tools we use today is much better at making sure that something is mechanically correct, that the code and the output of the code matches patterns that we know of. But like Jennison just said, when things are absent, it's hard to verify that they're correct. And that's where we really run into problems. Go ahead, Cameron.
Yeah, that's a really good take. I think also thinking about the accessibility API. So automated testing can only really go as far, I mean, so far from what we've seen, as asserting on the accessibility API. So does the surface area of the content expose its semantics? For example, if we know that if we have an image, we need an accessible name. We know that if we have an input, we need an accessible name. And that's easy enough to test. But testing the intention of the designer or the developer is much more challenging. So I think echoing what both Jesse and Jennison said, if you have nothing to sort of hang your test on, then it's really very difficult to get started.
Yeah, that's a good point. It makes me think of trying to do keyboard testing when something's not reachable or operable. There's kind of nothing to programmatically hang your hat on. And so that's where we have to start getting creative and using computer vision. Like, okay, cool. That means that we're not limited by what the code can automatically find, because otherwise the tools that we've been writing, all these years have been looking at what's the element tag name, what, we have limitations cross-platform with what we can do to sniff out if there's JavaScript events attached to it, and we can get really nerdy talking about event delegation and the pitfalls cross-platform of how you can't, there's just roadblocks. And so we have to get inventive about identifying these elements and go revolutionary new ways. And so what Gal was showing us was a demo extension that could look at the likelihood that a pattern on a web page visually looks like something, and then you can compare it to what the code is doing. But yeah, I think we've had difficulties, huge gaps of pages have had issues that couldn't be found automatically, and that's how we end up with the lighthouse scores that are perfect but the website's totally inaccessible. We don't want that to be the way that it is, but there's a lot of nuance and kind of edge cases, and some of them are just due to limitations in the platform that we've been running into.
Yeah.
Cool. Well, all right, we're off to a good start. Super fascinated to hear your takes on all of these topics. So for our next question, I would like to talk about color contrast algorithms a bit deeper. So even though we know color contrast is possible, we see it operating in modern tools today, but there are deep technical challenges involved with DOM structures, performance of these algorithms, edge cases where maybe the CSS styling has a background applied with a border or a pseudo element or something kind of atypical, but not, it happens. And so automated tooling needs to be able to sample these colors, no matter how they're applied. And yeah, I could totally geek out on that. But I would love to ask the panel, do any major pain points come to mind for you with color contrast or visual contrast testing? And Cameron, let's start with you.
Sure. Yeah. The main thing that I think of is performance. So depending on the environment that you're running in, if you're running a plugin in a web page, well, let me back up. Testing color contrast requires a rendered page, or if you move all the way up the stack into design, you can test color contrast in your design comps. In a rendered page, the technical challenge is performance of the algorithm for traversing like all of the background elements. So generally color contrast tests look at the color of the text and whatever's behind the text. But what's behind the text is actually sort of difficult to calculate, and it can be expensive. So if you were running automated tests in like a staging environment, for example, like this sort of my ideal, one approach to testing is to run it as like a logging system. So if you wanted to have like in your staging internal environment, you wanted to have accessibility tests running, and maybe those would be traced back to a dashboard, you would probably not want to run color contrast testing because it would slow down the experience of your internal users to a point where it would be noticeable. So, so I think thinking about performance, thinking about just sort of the mechanics of like traversing all of those elements, but maybe we're thinking about it the wrong way. I mean, the other big challenge is like, what do you do when you have a color contrast issue in production? Like the ship has kind of sailed from a design standpoint. So if you are testing for color contrast, like move it as far upstream as you can. Move it into your like design guidelines, your brand guidelines. Move it into your design tooling. You know, Stark has a color contrast plugin for XD and for a variety of other design tools. Like start moving as much as you can upstream into design.
I agree. And I can't tell if my video is frozen for just me or anyone else, but I'm going to talk through it anyways. Okay, so any other thoughts on color contrast? Maybe Jesse?
Yeah, this really feels like a one of these instances where we need people to do our color contrast. I think for the simplest cases where we can look at like text and solid backgrounds, we can use algorithms and automated checks to get some signal and maybe turn that directly into tasks or issues. But for the complex cases, which are a lot of the cases, I think, you know, when we can offer a clue, like I was saying, a clue to pull in a human to make a judgment call and then pull that back into design, like Cameron was saying, you know, that's really where we can solve the majority of the tricky cases. And most color contrast cases actually end up being pretty tricky when it comes down to it.
Agreed. Yeah. I mean, even with Chrome, the accessibility color picker in Chrome DevTools has had some issues. Like if there's more than one, I think if there's more than one node on an element, it has a hard time looking at which colors it should be surfacing to you. And so you find that the color picker in Chrome DevTools, unfortunately, doesn't work very reliably because you can't always just have one node in an element, especially if you aren't controlling the source code. You're just, you know, checking it or, you know, testing it, remediating it. And so, yeah, it can be very complex, and it seems like whole new approaches are needed, like a, you know, color picker kind of thing where you're sampling the pixels, not looking at the underlying code, because there's just so many edge cases that you can just write code until you're just sick of writing code, but then you have this performance problem where there's all this code running trying to look at the page. So yeah, we need some revolutionary new things, and I think that's another one for computer vision. Okay, well, it looks like I'm still frozen, so I might do some refreshing of my browser to fix that. But I think we can probably move on to our next question, which is about computer vision. So in your view, and we'll start with you, Jesse, how would computer vision and artificial intelligence improve accessibility testing, maybe in ways that we haven't already discussed?
In ways we haven't discussed. Well, let's I have a lot of frameworks, like mental frameworks that I use when thinking about these topics. And one of them is raising the floor and raising the ceiling. So when we think about what's the minimum that we can do with automated testing, we're talking about like what's the floor that we can get an application or a digital experience to that is the minimum viable level of accessibility we can do with our automated testing. And I think we can raise that floor up with our tests that look at code, that lint, that look at the rendered content and look at the mechanics of it, that look at the output and are just testing against patterns. Once you've done all of that, and you think that the rendered code is correct, that's when we start talking about, well, can a human actually use this thing? And when we ask that question, we're talking about semantics, we're talking about meaning, we're talking about interaction. That's where we need a tool that can bring those evaluations to bear on an experience. And that's, I think, what the promise of machine learning and these tools is. We're still at this beginning phases, but that's what we're really starting to ask. And these are the questions that we're starting to answer. So when machine learning tools can say, hey, human, we think there's an issue with the semantics of this, or the or with the way that the interaction seems to be intended here. Come take a look. That's where we get the power of machine learning. But building, like, there's the ability to just have that signal, and then the system around it that pulls the humans in and lets them work with that signal in a way to log it, to create a task, to then get that task to the right person, fix it, verify it. And that full system is really the complex bit for an organization or a company that they have to figure out.
Yeah, I would agree with that. I mean, I think machine learning, I think about Amazon's ground truth service, where there are multiple layers of machine learning, artificial intelligence that fall back to basically Mechanical Turk, which is a human being. And they've created a pipeline for doing that. Think something like that for accessibility, where we say, I mean, exactly what Jesse is describing, like, hey, machine learning thinks it's an issue, automate that step to get flagged for review. Like, a really streamlined platform for doing that would be amazing. And I don't think we have that yet, but there's opportunity there maybe.
Yeah, and it sounds like from what Jesse was saying, and we want to underscore, is we're not trying to just like solve it all with AI and just, neatly wrap it up and not have to ever have humans look at it. That's not what we're talking about, but using computers in ways that we can make it less tedious, less error prone, perhaps, things that can be done with certainty to uncover the problem and get it in front of humans to review. I know Facebook, Jesse, you've shown some things in the past, just around like productivity and the process of getting humans involved with testing. And so we can use code to uncover things, but ultimately it's the system and the process of having, testers and engineers actually look at this problem, not try to fix it automatically. At least that's what a lot of us are working on. Okay, so I want to keep this moving so we can get through some more questions. I'm going to skip ahead a little and ask one to you, Jennison. How can we keep accessibility testing simple enough for novices and non-experts to understand while not missing important nuance or detail?
Sure. So when I think about this, there's three types of the automated testing that come to mind right away. You have plugins, you have browser extensions, are two of those, and what we need more of these. And Cameron brought this up earlier in the discussion. It's about shifting left, like bringing it into as early in the process as possible. So in the design phase, and making it possible to interlink the tooling, so that when you're handing off between design, engineering, and testing, all these tools are complementary with each other. The other thing, of course, and the obvious one is we need as good documentation as possible so that the novice folks, and there are a lot of them out there, people who know nothing about accessibility, they're going to run a tool, and if they can't interpret the results, and if they don't have documentation to help them understand what those results are, they're not going to be making smart decisions about how to fix an error, or even understand what they need to do to fix it. So we continually have to better our documentation, better the messaging that pops up, and also help people understand severity of issues. I think that's another area where people get locked up and they're not sure exactly how severe an issue is. Sure, tools can say that's a Sev 1, but people need to better understand, what does that exactly mean? And what does that mean for people with different disabilities or different impairments? So, and by the way, it is early in the morning here. The third group of tools I was thinking about were linters.
Yes.
Yeah, 100%.
I
mean, I agree.
Oh, go ahead, Cameron.
Oh, please, both of you fight over my answer.
Well, I mean, echoing what Jennison said, I mean, also keeping in mind that there are different audiences for different tools. Mm-hmm. So Jennison mentioned linters. Linters are used for engineering and developers. Design plugins are useful naturally, mostly for designers, but also for PMs and stakeholders who are reviewing designs. And then CI tooling, mostly engineering. Then there's like QA folks. So like there's really a diversity of audiences for testing. And so keeping that in mind when we're designing tools, like who's your audience? And it's interesting, like the accessibility of accessibility tools. Like I think
I was just going to bring that up.
Sort of,
I was just going to bring that up.
Yeah. That like I know that Acts, the Acts plugin, they've done a lot of work to make sure that the plugin is accessible to people using assistive technology. And it's super important, especially in a field where there are people who are domain experts by virtue of the technology that they use day to day that should be accommodated for these tools. So it's something to think about.
Yeah, just to raise that point, just to reiterate that point, we always talk about the fact that we do need more people with disabilities involved in all the processes. And so if we fail with the tooling, we're excluding folks with disabilities from that opportunity to be part of all of those processes.
Totally agree. Yeah, and it goes back to what we were talking about earlier. If the syntax analysis can't catch something that's not keyboard accessible, for example, how is a blind tester going to find it? You know, how are you going to be able to go through this page if the code can't find it? So we need to employ different strategies in order to highlight accessibility problems in ways that don't rely on vision. And so the tools, definitely important to incorporate that. And hopefully that's just like, we can drill in this meta point that everything needs to be accessible. You know, the authoring tools, video platforms, I mean, everything. It's about access and inclusion. And so just, yeah, we have like one big message, and that's like, make everything accessible, including the tools.
And Marcy, part and parcel with that, as we said before, is also usable, right? Because we're going to have people who are going to be hopped onto using these tools who know nothing about accessibility. And as I said before, if the UI isn't intuitive, if the messaging and documentation is scant or too deeply technical or not understandable, people are not going to know how to interpret the results or how to fix them if the tools themselves aren't intuitive.
Yeah, I mean, on the flip side to that, Jennison, if you're an engineer who does have experience in accessibility and wants that very specific messaging for efficiency or for clarity, like it goes both ways.
Yeah, no, absolutely. It would be great to have more of those folks, though, right? We need more engineers who know that at that
exactly.
technical level.
That would be a nice problem to solve. I also think about, with regards to testing for design, making sure that there's like a diversity of tools out there. So Jennison kind of hinted at this, that there's no silver bullet, because there's so many different parts of the software development pipeline, like pieces of this puzzle. There's room for a lot of creative tooling. So I think the more diverse entry points we can have into building for accessibility, the better. And then also I wanted to mention that Adobe has been doing work around authoring in Adobe XD. Last year, I think we launched voice control support for Adobe XD. So that's in the spirit of what we're talking about. Like, I should be able to design what I'm using, right? Someone with a motor impairment should be able to design. Someone who's blind should be able to design and create. And Adobe's pushing that forward.
That's awesome. Yes. I did work at Adobe for a hot minute, and that's such a big part of the, why we do all this, is to enable the design and development process for people. And so it's really great to see that come together at such a big scale. Okay, so we've got a couple of minutes left, and we've gotten a few questions. This one's sort of related to what we were talking about. How do you bridge the gap between folks who are just starting to learn about accessibility and who think that running Lighthouse has them covered, Lighthouse being one of the automated tools built into Google Chrome? So for people who think that Lighthouse has them covered, and folks like ourselves who are deep in accessibility, how do we bridge that gap?
Well, sessions like this, right, where we are publicly talking about it, and hopefully we'll, because this is over YouTube and it's being captioned and all that good stuff, it's going to be widely accessible that way. But it comes down to documentation, having really, in my mind anyway, having solid documentation, and just to help people understand the purpose of each tool and what it's intended to be used for, and what it cannot help with.
Yeah, I agree, because we can then try to describe some of these technical challenges. Like, that you want the technical detail, like the going into the weeds kind of stuff, like we talked about earlier. But then you also have to balance, the cognitive complexity of trying to learn all of it while you're just trying to fix something. And so it's like we kind of need that range and detail, maybe having a high level description that is in plain language that explains something for someone who's trying to get the job done. And then if you're interested and, have the time to go into a detailed explanation, could talk about the background of a validation or something like that. Let's see. I want to make sure that we've gotten all our juicy questions answered. Do you have any tips for learning about accessibility testing algorithms? Let's see. Jesse, you might have some suggestions. Where did you learn about algorithms for accessibility?
So I read the specs. They feel long, they feel complex, but I promise you can. So reading the Web Content Accessibility Guidelines, WCAG, looking at the Authoring Practices Guide, or what's referred to as the APG online, and looking at the code examples there is a good way of seeing the practice from the theory and how those are implemented. And then looking at open source projects and reading their code, looking through the rules and acts. They're very well written and atomic, and you can look at like each little rule and see what the code, the logic is doing in there. So spending some time maybe digging into the weeds a bit over a couple of evenings or a weekend, and that's a good place to start. If that's how you like to learn, let's say it that way.
There's
Yes.
yeah, agreed. I mean, I think also looking at the accessibility API and the accessibility tree in Chrome, just digging around. I mean, for testing, there's a couple ways of testing content. You can actually assert on the HTML and try to calculate validity or intent that way, or semantics that way. Or you can look at the accessibility tree that gets generated by that HTML. So it's the equivalent of like static analysis of code versus like an end-to-end, like a unit test versus an end-to-end test. End-to-end test, you're just saying like, hey, I'm a user. I don't care how you built it. I just want it to have an accessible name. And a unit test might be like, well, this ARIA attribute is invalid. The value is invalid for this role. So if you start by thinking about the accessibility tree and how it gets generated, you might not even need to care initially about testing algorithms, because things like Puppeteer and Playwright, for example, you can assert on the accessibility tree by taking a snapshot of what the browser is actually servicing to assistive technology. So as just scratching the surface, as you get more, like it's an outside-in approach where as you get more interested or expertise in accessibility, you can start digging into, like, even at the very lowest level, how the browsers implement accessibility name generation. So like dig into WebKit and like dig into Blink and see like how does Chrome actually build these things. That's like on the far end of the spectrum. But the nice thing about what Jesse said is that there's, yeah, exactly, very far. There's so much in between, and there's so much open source tooling out there that it's just pick something and dig into it.
Yeah, I can say for myself, working on Xcore a number of years ago, I mean, looking at color contrast algorithms and trying to add support for pseudo elements and, you know, weird like inline text fields that have different like inline versus block elements. If you're trying to sample color contrast on those things, those details are important. And then you get into the performance aspects and, yeah, trying to write your own accessibility testing tool, I think would be my suggestion, because everyone thinks it's easy. They're like, oh, I'm just going to write a new accessibility testing tool. And then you get into it and you go, oh, okay, this is complicated. And if there's updates to the ARIA spec or browsers change or there's some legacy assistive tech that we need to keep track of, and like all of that detail, that's why using these tools is so useful, because the tools are in the business of, you know, keeping all of that into the code and so that you benefit as a user of those tools. Okay, so we're at the end already. It went by so quickly. It's just like old times, being in the hallway track at a conference. I've really missed all of you.
Yeah,
So
likewise.
yeah, we're ready to wrap things up. So we've come to the end of our first event for the Evincible series of accessible deep tech talks. And hopefully you've learned some insights that could help your understanding of where we are and where we're going with accessibility test automation. To stay tuned for future events, you can register on evinced.com. You can also follow Evinced_A11Y and myself, Marcy Sutton, on Twitter and LinkedIn. I'm sure we'll be sharing updates there. I want to thank our panelists, Jesse, Jennison, and Cameron, as well as Naveen and Gal from Evinced for providing their time and expertise in discussing accessibility. So thanks again to the Intelligent Hoodlums for organizing this event series and ACS for providing our captioning. Thanks to all of you for tuning in. If you have any questions or feedback about this event or the product demo that you saw earlier, feel free to email info@evinced.com.